In this video, I'm going to explain Green's lemma. This is a very short statement of the lemma. Let us try to understand the equation that has been written over here. The C that you see over here is a certain curve in the two-dimensional space. This curve encloses a collection of points. So the collection of all the points enclosed within this curve is S. The left-hand side is referring to this curve C. It is an integral over this curve C. The left-hand side is a line integral. The right-hand side is a double integral. The integration is carried out over all points of S. And what Green's lemma says that these two integrals are the same. The line integral is same as the surface integral. What is f bar? F bar is a vector field. So at each point on the curve and within, so if x comma y is a point of such a kind, you can think of this as the tail of the arrow. The arrow itself is the vector f bar. So you can imagine that at every point of S, there's an arrow like this. And therefore we say that f bar is a vector field on S. Now it is clear what these partial derivatives are. So f1 xy is a scalar value. f2 of xy is a scalar value. So f1 and f2 are scalar valued functions of x, scalar point functions. And what you have over here is the partial derivative of f2 with respect to x and the partial derivative of f1 with respect to y. What is the physical interpretation of Green's lemma? Now if you think of f bar as the force, then f bar dot dr bar is the work done when some object is traveling a short distance. And therefore if you add up all such works, what you get is the work done over C. What is dr bar? Now r bar is always going to stand for the radius vector. So r bar is going to stand for xi plus yj. And therefore dr bar is dxi plus dyj. So if f bar is the force, then the left hand side indicates the work done when the vector field acts on some object along this curve. And what Green's lemma is saying is that the quantity that you evaluate on the left hand side can be obtained as a surface integral, a phenomena which is taking place on the curve can be captured on S by such a calculation, or vice versa, something which is happening within C and that quantity is the right hand side can be captured on the boundary, which is the left hand side. Now if f bar is not force but some other quantity, for example if it is a velocity vector field, then in that case the left hand side cannot be interpreted as work, but it will be some other physical quantity. And similarly the right hand side will have a different interpretation. This kind of a statement will not obviously will not be true in general. So we will just assume that the vector field f bar, the curve C, the surface S have all those nice properties which allow such a statement to hold. Now I shall, through an illustration, show you how to carry out these computations.